So let's look at this picture. This is a triangle. You might recognize it as a 30, 60, 90 triangle, but we're just given that we're looking at a specific angle, and we have the opposite side is 1, the adjacent side is square root of 3, and the hypotenuse of that triangle is 2. And it's pretty easy to find the trig ratios of this triangle. We don't even need to know what theta is. Like I said, it's a 30, 60, 90 triangle, but if you didn't know that, you could still figure out all these trig ratios. It'd be very simple. Just sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, cosecant is just the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And if we don't even if we don't know one side, like if we didn't know that this side was the square root of 3, we could just use the Pythagorean theorem, and we find that 2 squared minus 1 squared is 3, and square root of 3 is the length of our side. So let's look at a different problem. What if we're given a sine value? We're given the value of sine, and we're told it's 24 over 25. How can we figure out all the other trig ratios? Well, we know that it must refer to a right triangle. We know that sine is the opposite over hypotenuse, and we have sine is equal to 24 over 25. So the opposite is 24 and the hypotenuse is 25. And we can use the Pythagorean theorem just like we did in the last problem to get the third side. 25 squared minus 24 squared is square root of 49, which is 7. And then from there, we now have the same problem we had before, and we can figure out all the other trig ratios. This may be a new concept to you, but it's pretty clear how that works. You just make the triangle. But how can we figure out the value of theta? How can we figure out what angle we're referring to? And we actually cannot. This problem is not enough information. You can type in your calculator. If you type in the inverse sine, the arc sine of 24 over 25, you get this first number, 1.287. But you'll find that a lot of numbers you plug into sine will also give you 24 over 25. If you plug in negative 4.996, you'd also get 24 over 25. Plug in 7.570, it's 24 over 25. Sine of 1.855 is 24 over 25. So how do we know which one of these angles is correct? So let's look at a different problem. Let's look at cosine of 3 pi over 4. To solve this, I would use the unit circle. And what we would get is we would look at the angle 3 pi over 4, which is also 135 degrees, and we would look at the x value at that point on this unit circle, and that would be negative square root of 2 over 2. So you can also notice that we make a pi over 4 radian angle right here with the negative x-axis. So if you were to draw this triangle going straight down here, you would get a right triangle with as a 45, 45, 90 triangle for pi over 4, pi over 4, pi over 2 triangle. And you could find out that the length of this straight up and down line would be, the length of this adjacent line here would be square root of 2 over 2, and then since we're in the negative x direction, it would be negative square root of 2 over 2. So let's also look at the sine value. Sine value is going to be the y value. So the sine of 3 pi over 4 should be square root of 2 over 2. But the sine of pi over 4 is also square root of 2 over 2. So we have two different values of sine, two different angles to plug into sine that give us the same value out. So whenever we apply the sine function to 3 pi over 4, we get square root of 2 over 2. We also get square root of 2 over 2 when we plug in pi over 4. So there's two different angles that give us the same answer. So having a sine value of sine theta equals square root of 2 over 2 could mean that theta is pi over 4 or is 3 pi over 4. And either one would give us the right answer. We could even, what if you went all the way around the circle, 2 pi, you can add 2 pi to either of these angles and you would still get the same answer. So there's actually an infinite number of possible solutions to this problem. So thinking back to our original problem, we could assume that we are actually in the second quadrant, that our triangle is in the second quadrant. So we're looking at sine of theta equals 24 over 25. And the positive sine value means the fact that 24 over 25 is positive means that we are working in either quadrant 1 or quadrant 2. And the adjacent side still has a length of 7, except for now it's in the negative direction. So we're going to make that a negative 7. Even though the length is 7, the x value should be negative 7. And so from here we can figure out all the same values, and you'll notice that these are actually the same, or not the same, but it's very similar to the values that we got before. And the green boxes are the first answers we got, and down at the bottom here is the second answers we got with the negative values. So they're very similar, it's just some are negative and some are positive. But it's the same numbers, it's just some are negative and some are positive. We might want to think, well, how do we know when we're going to get a negative answer and when we're going to get a positive answer? And so we're going to look at the x and y values in that quadrant that we're working in. So when you're given a problem, you're going to be told that you're working in the first quadrant, second quadrant, third quadrant, fourth quadrant, or you're going to be told something about where the angle lies. And in the first quadrant, all of the trigonometric ratios are positive. So any angle between 0 to 90 degrees gives you a positive value, no matter which trig function, cotangent, sine, cosecant, any of those gives you all positive. And then in the second quadrant, only sine and cosecant are positive. All the other trig values will be negative. You'll notice that all the x values of these points are negative, because those would be the cosine values, and then tangent would be sine over cosine, the slope of this line. So it would also be negative, because it would have a positive over a negative, and then all the other ratios would just be inverses of those. So they would still either be, the cosecant would be positive, and then secant and cotangent would be negative. And then we can go all the way around the circle and we can see which quadrant. And you maybe want to memorize this, but you don't really have to memorize all of them. You could just remember that all are positive in the first one. Sine is positive, so that means cosecant is positive. Tangent is positive in the third quadrant, so that means cotangent must be positive. And cosine is positive in the fourth quadrant, and so secant must also be positive. You can memorize this by going I use the mnemonic all seniors take calculus. This would be A, first quadrant, seniors, and the second quadrant, so S, take, T for tangent, and C for cosine. So you could memorize that, or you could just look at the x values and y values. And so here's some questions to think about. Why might we still not know theta even if we know what quadrant we're working in? Another question is, find the values of the other ratios if the secant is undefined and theta is between 0 and pi. So theta is in the first two quadrants It's an angle in the first two quadrants, and secant is undefined. And then use this to explain why cosine of theta also equals cosine of 2 pi minus theta. It's interesting, you can think about this geometrically, about the positive, when cosine is positive and when cosine is negative. That explain why this happens.